Hello, class. Too strong. I'll be more myself. How about that? Since the only people listening are you people, you're just listening at home. So, pre-calculus is very much, I think of it as two classes. You have before Christmas and after Christmas. Before Christmas, it's basically Algebra 3. You're going to be looking at graphs. It's going to be a lot of functions. It's going to be repetitive stuff that you've done in Algebra 2, but maybe taken to a higher level of thinking, where you're going to be dealing with more with graphs, what the graphs are doing. Then after Christmas, you're going to get into trigonometry. You've done the very basics of trig. You've done the beginning, but you're going to do the whole second half of the year will be trig like you've never seen before, with sometimes having vectors thrown in. And we're going to also look at a little bit of like geometry and conic sections, which I am not great at. So, but that's new to the course of study this year. So here's an overview. In chapter 1, we're going to be introduced to the concept of a function. So I asked my last class, does anybody know what a function is in math? Like right now, could anybody explain to me what a function is? No, that'd be a point on a graph. You're right. That was an answer, which is better than everybody else. Everybody else pretends like they have no idea, or they don't have any idea, and both are bad. So, being a function, that's not really super important right now. We'll talk about it next section about what a function is. But you were introduced to functions when you were in 7th grade. And you've only done them in 8th grade and Algebra 1 and Algebra 2 since then. But, so, you can see one of my big focuses that I'll do in pre-cal is understanding terminology. What does something mean? Where does it come from? A function is something that everybody in here should know, and none of you did. Right? And that's normal for pretty much every class I've ever taught here. We're not good at terminology. We're not good at definitions of what things are. And so, again, my goal is you are going to be quickly going off to college, some of you, and other places where other people are going to teach you math. And then they're going to talk about a function, and you're going to say, I don't know what that is. And then they're going to ask next. You know what they're going to ask next? Especially go to Northeast. Well, what high school did you go to? And then guess who you're reflecting on? Every math teacher you've ever had. Because they know us. So, for that reason, there may be some things that you're used to saying, like FOIL, that I'm trying to break you out of that too, because that's not a very intelligent thing to say. Right? Just fold that out? No, we're not folding that out. We're distributing. But things like that, I will focus on throughout the class. So functions are going to be one of those, but that's going to be next section. Anyways, let's keep going what we're going to do. We're going to be introduced to the concept of a function. As you proceed through the text, you will see that functions play a primary role in modeling real-life situations. There are 3 basic types of functions that we have proven to be the most important in modeling real-life situations. These functions are algebraic functions, exponential and logarithmic functions, and trigonometric and inverse trigonometric functions. These 3 types of functions are referred to as the elementary functions, though they are often placed in 2 categories of algebraic and transcendental. Each time a new type of function is studied in detail in this text, it will be highlighted in a box similar to those shown below. The graphs of these functions are shown on the inside cover text. So right here, that's not it. Right here would be our, we're going to first look at our algebraic functions. So all these functions should look familiar to you. We have linear functions that are of the form f of x equals x. So that's your y equals x. Everybody's favorite, y equals mx plus b. Right? All those are linear. That means when you graph them, they draw a line. Next is quadratic. You should have been introduced to that in Algebra 2. So quadratic function, those graphs are parabolas. Right? You should have seen those. Cubic functions. You may have seen a cubic function, but you may not have graphed it. Did y'all graph cubics? No. Okay. So we'll see what they look like in chapter 2. Rational functions. Those are fractions where the variable's in the denominator. Those are fun graphs. We get to talk about lots of words that you've never heard before there. And then square root functions. Have you graphed a square root function before? Do you know what that looks like? So all these things, all these functions, before this 9 weeks is up, you're going to know what every one of those functions graph looks like in a general form, and you're going to know properties about those graphs. So those are 5 of our basic algebraic functions. Now the next one, these are called transcendental functions. So the first one is an exponential function. That's when our variable is going to be in the exponent. So something like 2 to the x, 3 to the x. You may have done some stuff with e to the x in a science class. Maybe if you're doing exponential growth, exponential decay, or maybe you haven't, but that's fine. We'll be looking at stuff like that. E to the x, where our variable is in the exponent. Next is logarithmic. They told me that y'all have done logarithms before, some sort. We're going to be graphing logarithmic equations, and also we're going to review all their properties and work with them. And then trigonometric graphs. So I know you haven't seen what any of those look like yet, but we will get there when we get there. That's chapter 4 before we ever get to those graphs. And then we have 2 non-elementary functions that we're going to be introduced to. The first one I know you have seen before, an absolute value graph. Maybe you haven't seen it, but you know what an absolute value is. And then greatest integer, that's sometimes called a step graph as well. You may or may not have seen that. They're kind of more unique. Okay, here is chapter 1, section 1. Lines in a plane. So we're going to start very simple. You should all be very comfortable with this section. You all have graphed lines in a plane before. This is what you should know how to do by the end of the class, or by the end of this section. Find slopes of lines, write linear equations given points on lines and their slopes. We're going to use slope-intercept form of linear equations to sketch lines, and we're going to use slope to identify parallel and perpendicular lines. So again, if at any time you get where I'm being observed in class, and they're like, "Hey, so what are y'all doing today?" You can go right back to this. Right? That's your list. That's what we're doing. Just go find it and say, "This is what we're doing." You can read it. Well, we're finding the slope, and it's all right there. All right? Great. Go find it. All right. So let's first talk about slope of a line. So I'm going to ask you, how would you define the slope of a line? Not what the book says, what you say. Sand Mountain vocabulary, Sand Mountain definition. What's the slope of a line? How it goes up?
What it looks like.
Okay, so how it goes up, I might could get there. That's one that you hear a lot. Rise over run. Absolutely. That's what slope is. Anything else? What does the slope describe? I know it is the rise over run, but what does the slope describe in a graph? It is a ratio. All right, it's a ratio of the rise over run, which we can call the change in y over change in x. We can call it delta y over delta x, right? All those are different ways to say rise over run. What are you saying? Okay, so it's not the distance. We do use 2 points to find the slope, but distance is literally how far am I from this point to this point. Slope doesn't tell me how far I am.
It's the rise or fall from 2 points.
So yes, it could be rise or it could be a negative rise, which the book uses fall for that. But you know more about slope than what you can say out loud. Like if I ask you the slope of this line, what can you tell me about the slope of that line? It's positive. How do you know it's positive? That it goes up this way? Yeah. So Correct. When we read graphs, we should read them like we read words. How do you read words? Left to right. You should read graphs from left to right. So when I look at this line from left to right, it is increasing and going up. Therefore, I know that has a positive slope. If it is not going up, if it is decreasing from left to right, that is a negative slope in the red. Okay, now looking at the black line versus the yellow line, both of those have positive slope. Agree? Which one has a greater slope? How do you know? Say it. It's steeper. What is slope? It's how steep a line is. That's what slope is, right? Slope tells me how steep a line is. Now we have all these other things we can say about it. Positive slope, negative slope, all that. Again, you know more about it when I start asking you questions, but if I just ask you, what is slope? What is slope? It's the steepness of a line. It's the rise over run. Delta y over delta x. Change in y over change in x. All those are what what the slope of a line is. In this section, we're going to study lines and their equations. The slope of a non-vertical line represents the number of units the line rises or falls vertically for each unit of horizontal change from left to right. So that's real fancy, them saying rise over run. That's all it is. Same amount of vocabulary, it's a rise over run. Now, one thing that I want to highlight, and you see I already did in the last class, is non-vertical line. What does that mean? If it's a because that sounds real fancy when you read that out loud. The slope of a non-vertical line represents. Okay, well, what are they saying? Yeah, so a vertical line is straight up and down, so it can't be straight up and down. Why are we not talking about the slope of a line that's straight up and down?
You can't define it.
Well, we can find it. That does have a slope. What is the slope of a vertical line? Incorrect. How do we measure the slope? You've already said it. Rise over run. So how much am I rising? I don't know, 1, 2, 3. I'm rising forever. How much am I running? None. So what am I getting? I'm getting some number divided by 0. Yes, undefined. The slope of a vertical line is undefined. It is not math error. I got the slope to be math error. No, you just did a math error. That's not the answer. So vertical lines have undefined slope. So when we talk about slope, we don't want to talk about vertical lines. Also, vertical lines are not functions. But I know that y'all don't remember what a function is, but they're not one. All the other lines are, but not a vertical line. But again, we'll talk more about what a function is tomorrow. Let me go back here. Well, actually, that's... All right, so the next thing that we see is this real fancy looking graph. So when y'all look at that, what thoughts go through your heads? Yeah. So that's another thing that I'm really big on is I would say at least 80% of you looked at that and said, I quit. There's not a single number up there. It's madness. Okay? But it's really everything that they're displaying for us, you are familiar. Look. Now, what are they saying here? Go back to this. I have what? What are these? These are 2 points. What are their values? Anything. That's the whole point. This works for any 2 values. It doesn't have to be 1, 2, and 5, 4. It can be anything. So for any 2 ordered pairs, if I want to know the change in x, what do? I subtract one of the x's from the other one. And that tells me how much the x's are changing by. Then I look here. How much are the y's changing by? We just subtract one y from the other. Right? That's all that graph is showing. It looks real complicated, but if any of you are going to go to higher level maths, that's the way they talk about everything. Okay, so you got to get used to seeing that. You can't let that be oh, I'm scared, I don't know. Yes, you do. Just use real examples, like what we did before. Plug in real numbers and see if you can make sense of it. So that's all that's. Okay, so let me make up my own example. All right, say that I have 2 points. The points are 1, 2, and 5, 4. 2 points. Now, what did y'all tell me that slope was? It's the rise over run. Now, we use the variable m, and I'm sure you know that, to represent slope. If you ever see an m in math, it's probably talking about the slope. So the slope is the rise over run. So when I look at this, let's first figure out how much am I running. So the run is basically how much are my x's changing by. Right? That's all the run is. So what would be the value of that blue line? What's its distance?
4.
It's 4. And how did you get that? We took the x value of 5 and subtracted the x value of 1, which meant that the x's were changing by 4. Now when I look at the green line, that would be my rise, right? Or my change in y. How much are my y's changing by? 2. And we get that by doing 4 minus 2. So we could say here the slope of this line would be 2 over 4, which is equivalent to 1/2. Did everybody follow that process? What we just went through? So because I'm subtracting the y's and I'm subtracting the x's to find the change in y and the change in x, I'm really just deriving the slope formula, which again you should all be familiar with. The slope of any non-vertical line passing through any 2 points is given by this formula. Slope is y2 minus y1, which is the change in y, over x2 minus x1, which is the change in x. Delta y over delta x. Rise over run. Have I said it enough times yet? Okay, now this is just really the only way that you can mess up using the slope formula. Whenever I have an ordered pair, so say, let's just use that same example. If I have 1, 2, and I have 5, 4. If I choose to make this my first ordered pair, I call it x1, y1. If this is my second ordered pair, I call this x2, y2. What if you had a different first ordered pair? Doesn't matter. If you call this x1, this has to be y1. If you call this x2, this has to be y2. The only way you mess up the slope formula is if you mismatch. If I call this x1 and this y2, then you're going to get the wrong sign. Okay, so that's what they're saying there. Make sure you do not mismatch. Surely you wouldn't do that. But people have done crazier things. Normally what I do is I pick, if I have 2 points, whichever point is farther right is always going to be my second ordered pair, because I'm reading my graph from left to right. Again, it doesn't have to be that way, but that's a general rule for me, so that way I know, hey, I'm not messing up here. The slope of that line? 5. What do you guys think? Y'all like 5? That is incorrect. It's not 5. What should it be? 1 over 5. Remember, change in y over change in x. My rise over my run. That means the y's go in the numerator. The x's go in the denominator. So this tells me to find the next point. I would rise 1. I would run 5. Questions? 0. What'd y'all get? Y'all agree? I agree too. 2 minus 2 is 0, so that's the number on top. And then you should have a 3 on bottom. So 0 over 3 is just 0. So what kind of line do we expect that to be? If I were to graph it, be a horizontal line. All right, and then C part, pick a number, 1 through 5. It's 3. How many people do I have? 2. Pick a number, 1 through 2.
2.
It is 2. All right.
Yeah. -5.
-5. What do you guys think? I agree. That means that this one, you would go down 5 and to the right 1. So it would be a negative sloping line. And again, we've already talked about most of these things. A line that has a positive slope will rise from left to right. A line that has a negative slope will fall from left to right. So we've got to make sure we're reading graphs, just like we read words, from left to right. A line that has 0 slope is horizontal. So that is a 0 slope line. It's a perfect horizontal line. A line that has undefined slope would be vertical. So that's straight up and down. So again, nothing crazy different that you don't already know. Just kind of putting it in words. One thing that people get confused the most is horizontal 0, vertical's undefined. A lot of people call vertical 0. So just make sure you are aware. Is point slope form for the equation of a line. So I know that I think at least the majority of you had but slope-intercept form is not the only form of an equation. It is a form, but here's another form, which is point-slope form. Now, before we talk about point-slope form, I want to make sure that we understand what slope-intercept form is. So we said before it's y equals mx plus b, and we call that slope-intercept form. Now, does anybody know why we call it slope-intercept form? Okay, well, let me ask. What 2 things can you identify when something is in slope-intercept form? The slope and the y. So you can, I'll say it slower. You can identify the slope and the y-intercept. And what form do we call that? Slope-intercept form. You can find the slope and the y-intercept. It's amazing, right? And none of y'all knew that's why it's called slope-intercept form? Because you can get the slope and the y-intercept. Okay? Whoever's making this up is dumb. No, I mean, this really makes a lot of sense. Okay, next one. Point slope form. Oh, okay, so if slope-intercept form, I can find the slope and the y-intercept, then point slope form, I'm going to be able to find the slope and a point. Point slope form. Point slope form. Now, the y-intercept. Is the y-intercept a point?
Yes.
What is the y-intercept? So, okay, we got to make sure. What is y-intercept? It's the point that our line crosses the y-axis. It's a very specific point. The point where it crosses the y-axis. Now, what is true about all points when they cross the y-axis? No matter where my y-intercept is, what is true about that point? What is? Yes. No matter what y-intercept I choose, the x value is 0. Okay, let's keep that in mind. Okay, so given this form, this is called point slope form. So say I have some random point that's at x1, y1. And say I have the slope that's at m. We can say that point slope form is y minus y1 equals m times x minus x1. Okay, so one thing I want you to notice about point slope form, it has built-in negatives. You see how my y1 is negative and my x1 is negative. So whatever the point is, when it goes into the formula, we're going to change the sign of its pre-established sign. So, for instance, if I have, let's just use this hypothetically. Say I know that the slope of a line is 2, and I know that it goes through the point 2, negative 3. And I should have done this on the iPad. Hold on. That's what I told you. I'm bad about just going to the board. If I knew the slope was 2, and I knew that it had a point that was 2, negative 3. If I were to put that into point slope form, then that's going to give me a value of y minus y1. Okay, well, what's my y1? Negative 3. So minus negative 3 looks like plus 3. You see how it has the opposite sign from what it actually is. Equals m is the same times x minus my x1, which is 2. So this here would be point slope form for a line given a slope of 2 and the point 2, negative 3. Now, very quickly, before that lunch bell goes off, watch this. What if I knew that the slope was 1/2? Let's go negative 1/2 just for fun. And let's say I knew it went through the point 0, negative 2. So now I know the slope and I know a point. Well, what if I put this into point slope form? It would look like y minus y1. So that's going to be y plus 2 equals m times x minus x1, which is 0. Now watch. What is x minus 0? X. So I've got y plus 2 equals 1/2 times x. And now what if I want to get y by itself? What would that look like? I would subtract 2, and it would look like y equals 1/2 x minus 2. So now what form is it in? Slope-intercept form. Y equals mx plus b. What's the slope? 1/2. What's the y-intercept? Negative 2. Hey, that is a y-intercept because the x value is 0.
It's supposed to be negative 1/2.
It's supposed to be, it's been negative this whole time.
Oh, yeah, you're right. Sorry.